For a pole vaulter in training, the learning curve is given by P of t equals 20 minus 14 times e to the negative 0.024t, where P of t is the height she is able to pole vault after t months. How high should she be able to vault after 3 months of training? After how many months is she able to vault 12 feet? So first we're asked, how high should she be able to vault after 3 months of training? Here we just need to substitute in 3 for t to figure out her height. So we have P of 3 equals 20 minus 14 times e to the negative 0.024 times 3. And if we use a calculator to approximate this, we get approximately 6.97 feet, which is about 7 feet. So about 7 feet. The next question is a little bit more involved. We're asked, after how many months is she able to vault 12 feet? So here 12 is the function value, and we want to solve for t. So this would give us 12 equals 20 minus 14 e to the negative 0.024t. We want to solve for t, and so we want to get this exponential expression by itself first. We can subtract 20 from both sides. If we do that, 12 minus 20 gives us negative 8. So we have negative 8 equals negative 14e to the negative 0.024t. Then, to get the exponential expression alone, we can divide both sides by negative 14. A negative divided by a negative is a positive, and 8/14 reduces to 4/7. So we have 4/7 equals e to the negative 0.024t. And once we've done this, we can rewrite this in logarithmic form. When we do that, we're going to have the natural log because the base is e. So ln of 4/7 equals negative 0.024t. And to get t alone, we just need to divide both sides by negative 0.024t. And when we do that, we get ln of 4/7 divided by negative 0.024. And if we use a calculator to approximate this, we get approximately 23.3. So it'll take about 23 months for her to get to the point where she can vault 12 feet. Now, I actually want to take a quick look at the graph of this function so we can talk about why something like this might be modeled off of an exponential function. So here we have the graph, and we notice that when t equals 0, the original value is actually going to be 6. When t equals 0, we've got e to the 0 is 1, 14 times 1 is 14, and 20 minus 14 is 6. So the average person with no training at all should be able to vault 6 feet, which isn't surprising because people are almost about 6 feet tall. That's, average height is just a little bit under 6 feet. And we can see here, based on this model, that with a little bit of practice, we can get up to 10 feet. Just 1 year of practice gets us up to 10 feet. But then after that, the amount that we're gaining slows down more and more and more. And it eventually is going to be asymptotically approaching 20. And that's because, of course, the more practice we get, the better we should be at something. But there is a limit to how high a human can pole vault. You're not going to have anyone vaulting 100 feet. That would be crazy. So really, we get quite better in the beginning when we pick it up and we learn the basics, but then to get closer and closer to the maximum value that we can get, it really takes a lot of practice, a lot of fine-tuning, and so our improvement ends up slowing down and getting smaller and smaller as we move on. With a lot of sports like these, with world records and with the Olympics, the difference between first, second, and third place can be inches or fractions of inches or seconds, depending on, if it's a race or something like that. And so that's why Olympic athletes train so much, because sometimes that tiny difference ends up making the difference between getting a medal at the Olympics and not getting a medal. So oftentimes with something like this, we have an exponential function, because exponential functions allow us to be asymptotically approaching a value, and that's exactly what's happening in this situation.